Hello all, welcome to Java programming from CodeBae. In this video, we will be discussing about variables and their types in Java. So far, we have discussed about history of Java, JDK, JRE, and JVM, different versions of JDK, JVM architecture, OOP concepts, what are OOP concepts, what is polymorphism, what is encapsulation, what is inheritance and all. We have also discussed about different kinds of keywords and the rules for defining the identifiers. Along with them, we have also discussed about the types of data types that are supported in Java programming language and also the rules of the naming conventions that has to be followed for defining class names, variable names, and method names. So now let's understand about variables. Generally, Java supports three kinds of variables. They are local variables, instance variables, and static variables. Before looking into the variables, let's understand few more things about the variables. The first one is Java does not support global variables. We don't have the concept of global variables in Java programming language. As we see in C programming language, we have the global variables, but Java do not support global variables. Only the variables that are supported by Java are local variables, instance variables, and static variables. And Java does not print the garbage values. Java does not print the garbage values. And the last one is we can have multiple variables with the same name, but the scope of the variables must be different. That means we cannot have multiple variables with the same name and with the same scope. Now, local variables. Any variable that is defined or declared inside a block is called a local variable. So if you just look this variable A that is defined or declared inside the block of this method. So the scope of this variable A is limited to this particular block only. We are not allowed to access the variable A outside the block. So the variables which have the limited scope or a block scope, those kind of variables are called local variables. Instance variables or static variables, the variables that are declared within the class level are called as instance variables or static variables. All the static variables are defined with a static keyword, and instance variables do not have the static keyword. So the non-static variables are called as instance variables. The scope of this static variables and the instance variables are available for the entire class block. So we can access this variable A inside the complete class block. But whereas the local variables, they can be accessed inside only one block. So if the scope of the variables are limited to single block, those kind of variables are called as local variables. Let's understand about the local variables. Variables declared inside a block. It might be a method block or a constructor block or as a parameter to a method. Any these kind of variables are called as local variables. As we already discussed, the scope or the visibility of the variables are limited to single block. If the scope is limited to a single block, then those kind of variables are called local variables. The other important point that we need to understand is all the local variables must be initialized by the programmers. If you're not initializing the variables and if you're trying to access them, compiler will be raising an error. So before accessing or referring or printing the local variables, they must be initialized. They must be initialized. Now let's look into the coding part of the local variables. Now, the variable args is passed as a parameter to the main method. So args is a local variable. That means the scope of this variable is limited to this particular method block only. Int We're defining a variable int a. We have not initialized the variable a. I have not initialized the variable a. This variable a is an local variable. As the variable is declared inside a block. And if I'm trying to print the variable without initializing, compiler will raise you an error saying that variable a might not have been initialized. If you can look over the error here, variable a might not have been initialized. So we are not allowed to access or refer to a local variable without initializing. So that is what we have discussed in the previous point, that is Java does not print the garbage values. The same code is written in, if you are trying to access any uninitialized variable in C programming language, we get a garbage value. But in Java, we does not get a garbage value. So the local variables must and should be initialized by the programmer. So if I'm trying to access the variable outside this method block, we are defining another method over here, void sum. So we are defining another variable over int c, and I'm trying to print the value of c. Right. Now, args is a local variable because that is passed as a parameter to the main method. So the scope is limited to this particular block only. A is a local variable which is declared inside the method block of main. So the scope or the visibility of this variable is limited to single block. C is also a local variable. So the variables which have a limited scope to a single block, those kind of variables are called local variables. Now let's try accessing the variable C outside the sum method. Now I'm trying to access this variable C in the other block. So we get an error saying that variable C might not have been initialized. Variable C cannot find symbol. Sorry, variable C cannot find symbol as this C is not initialized in this block. The variable C is limited to only this particular block. This is about the local variables. So the only points that we need to remember or understand about the local variables have the limited scope. That is, the scope of these local variables are limited to particular block or a single block only. All the local variables must and should be initialized before they are accessed. Now, A is a local variable. I have initialized it and now I'm trying to print it. So it prints 45. Java does not, and the last point, Java does not allow, or the Java does not print the garbage values. This is all about the local variables. So these are the 4 points that we need to understand about the local variables. Now, let's look into the instance variables. So if we look into this, so C is a local variable, args is a local variable, and 45 is also a local variable. So C can be accessed only within this block. Args and 45 can be accessed only in this particular main block. Now let's understand about the instance variables. The first and foremost thing, instance variables, the scope of these variables are limited to the complete class block. That means we can access these variables inside the class block of any method, inside the method of the class block, any method of the class block. So the first and foremost one, instance data members, whatever they are, it might be the variables or the methods, they cannot be referred from the static context directly. They have to be referred with the help of objects only. So whenever we have the instance variables, all these instance variables are not allowed to be accessed from the static context directly. Whenever you are referring from the static context, all the instance variables should be accessed with the help of objects. All the uninitialized instance variables will be initialized by default values of their respective data types. So as we have seen, all the local variables must and should be initialized by the programmer. They cannot be left uninitialized. But whereas the instance variables, it's not necessary for the programmer to initialize the instance variables. Instance variables, if they are not initialized by the programmer, then they will be initialized by the default values of their respective data types. Instance data members of one class, when you're trying to refer it in a different class, they should be accessed with the help of objects only. All the instance variables share different memory allocations with respect to different objects. So these are the 4 points that we need to understand with respect to the instance variables. Now let's understand about the instance variables. So as we have seen, a is an local variable. Now we are declaring another variable, int iv semicolon. Now iv is an instance variable. Iv, now this particular variable iv can be accessed in the main method, and they can also be accessed in this particular block. So the variable which have the class scope, they can be static variables and instance variables. And if the variables are not declared with the static keyword, then they are called as instance variables. Now let's try to print iv. So I'm trying to just refer the variable iv. From which context I'm trying to refer? We are trying to refer from the static context. So the first point that we have seen in the instance variable is instant data members cannot be referred from the static context directly. They have to be referred with the help of objects only. So now what we are trying to do is we are trying to do or refer the instance variable iv from the static context. So this statement must raise you an error saying that non-static variables cannot be referred from the static context. If we just look at the error here, non-static variable iv cannot be referred from the static context, where because iv we are trying to access it from the static block. So whenever we are trying to access the instance variables from the static context, they have to be accessed with the help of objects only. Now let's understand how do we create an object. The syntax for creating an object is class name. So the syntax, let's understand the syntax of creating the objects. Syntax for creating the object is class name followed by object name equal to, that is your assignment operator, followed by new constructor, followed by semicolon. So now let's understand this class name. What is our class name? For this particular class, I'm trying to create an object. So hello world. Object name, ob, any object name. We can define any object name. We can name it as with any name, followed by assignment operator, followed by new, and constructor. Constructor will have the same name as a class. So what is our class name? Hello world, followed by parameters and semicolon. This is how we create an object. Now let's create an object here. The syntax is class name. Class name is hello world. Followed by object name, ob, followed by assignment operator, followed by new, followed by constructor. Constructor will also have the same name as a class. Our class name is hello world, followed by parameters and semicolon. We'll in the coming sessions we'll discuss more about the constructors, but as of now, just remember this: constructors will have the same name as a class. Now we are referring it with the help of object. Object name is what? Ob dot variable name. So this is how we will refer the instance variables from the static context. Next point. Did we initialize the instance variable? No, we did not initialize the instance variable. Now let's check, do the compiler raise an error or will it print something else? If you can see here, we did not get an error, but instead of getting the error, we got a result called 0. So this is the value that is stored or that is assigned to variable iv. And how is this assigned? This is the default value. This is not a garbage value, but this is a default value that is assigned to the integer variables. As we have discussed, all the uninitialized instance variables will be initialized. All the uninitialized instance variables will be initialized by the default values of the data types. If you can see here, uninitialized instance variables will be initialized by the constructor with the default values of respective data types. So the default value of integer data type is 0. If this is float, if the data type is float, then it will print 0.0. So this is the default value of float. Double is also same. Byte, short, int, long. For all these data types, the default value is 0. So that is for integer data types, the default value is 0. For the float data types, the default value is 0.0. For the Boolean data types, the default value is false. Now it will print the false. And for the character data type, the default value is space. Just have the blank space there. So this is the blank space we can see here. So in this editor, all the empty spaces are denoted by dot. That is the reason we have seen that in this editor. But for the character, the default value is space. So all the uninitialized instance variables will be initialized by the constructor with the default values of the data types. So for every data type, we have the default values. For integer type, that is for byte, short, int, and long, the default value is 0. For float type, float and double, the default value is 0.0. And for character, the default value is space. And for the Boolean type, the default value is false. So we have understood about 2 points. The first one, all the instance variables, when referring from the static context, they have to be accessed with the help of objects. We are not allowed to access the instance variables or non-static variables from the static context directly. They have to be accessed with the help of objects only. The second point that we have understood is what? All the uninitialized instance variables will be initialized by the default values of the respective data types. Now, let's try to access iv in this block. Now, and now what kind of method it is? Did we write static here? No, this is non-static. That means instance. All the instance data members, when referred from the static context, they have to be accessed with the help of object only. So what is our object? Ob. So ob dot sum of 10. So as methods is taking an integer value as a parameter. Now let's run it. Space, we have got the space twice because this ob is printing and this iv is also. So when we are trying to access the instance variables within a non-static blocks, it's not necessary for you to refer it with the help of objects. You can directly and call them. But if you're trying to refer in the static blocks or static context, they have to be referred with the help of objects only. Now let's understand the fourth point. Instance variables share different memory across the different objects. Now we have one object OB. We are trying to create multiple objects for this particular class. For a single class, we can create any number of objects, but objects must have a unique name. So we are giving a unique name to the objects OB1. Now using these objects, I am trying to initialize the value OB dot IV equal to 23. Now we are initializing. So I don't want the default values. So I'm initializing the values here. So the next one is 33, 43, OB.iv, OB1.iv, OB2.iv. Now we have variable iv, and this iv is being assigned with different values with respect to different objects. Now we are trying to print ob.iv. Changing the data type to int. So now the result is 23. If we are given with 1, it will print 33. Now if we give it with, if I access iv with object 2, that is ob.2, it will print 43. So that is what the instance variables share different memory allocation with respect to different objects. That means now when we are creating the objects, 3 objects are created in this, right? The object name is OB, OB1 and OB2. With respect to OB, the value of IV is 23. With respect to OB1, the value of I is 33, and OB2, the value of IV is 43. So when we access OB.iv, this particular memory location will be accessed. When we access OB2.iv, this particular memory location will be accessed. That is what the instance variables share different memory allocation with respect to different objects. This is about instance variables. And the last point, when we have multiple classes, now we have only single class over here. Assume that we have a different class. Remove this method. So I'm creating another class. The class block is closed. Hello world class is closed here. So I'm creating another class, class second. In this class second, I'm declaring another variable int s, int r, and these are our class level variables. So, and as they are non-static, so we are calling them as instance variables. If I want to access yes in class hello world, if I want to access the particular variable s in class hello world, so whenever we are trying to access the instance variables of one class into a different class, they have to be accessed with the help of object of that particular class. So as variable s is present in class second, we have to create an object for class second. Say object syntax for creating an object: class name. What is our class name here? Second, followed by object name ob3, followed by assignment operator, followed by new, and followed by constructor. Constructor will always have the same name as a class. That's it. Now ob3 dot s equal to 55. If I just wanted to print this variable ob3 dot yes, now if I just run the code, it prints me 55. So this is all about the instance variables. So now just understand about the, just recollect the points of the instance variables. The first one, all the instance variables when referring from the static context, they have to be referred with the help of objects only. We are not allowed to directly access the instance variables within the static context. They have to be accessed with the help of objects. The second point, all the all the uninitialized instance variables will be initialized by the constructor with the default values of their respective data types. The default value of integer data types is 0. That is for byte, short, int, and long. If these variables are not initialized, then they will be initialized with the default value 0. For floating data types, for float and double, the default value is 0.0. And for character, the default value is space. And for the Boolean data types, the default value is false. Third point, all the instance variables share different memory allocation with respect to different objects. We have only one variable IV over here, but IV is holding multiple values, 23, 33, and 43. That is with respect to different objects. That means they hold different memory allocation with respect to different objects. And when the last point, when trying to access the instance variables of one class into a different class. So the variable of S I'm trying to access in class hello world. So when you are trying to access the variables of one class into another class, they have to be accessed with the help of objects of that particular class. This is all about instance variables. Now let's try to understand about these static variables. So I'm just removing the additional code over here. Now the same static variable, instead of IV, I'm declaring the variable name as SV. And if you want to declare the static variables, all the static variables must be defined or declared using the static keyword. Static keyword followed by the data type and followed by the variable name. Static variables can be referred from both static and non-static context. We don't have any restriction on the static variables. So they can be accessed from both static and non-static context. As this is a class level variable, this can be accessed in multiple blocks of the same class. Void. Yes, if I have another method called sum, and we can even access SV directly. SV directly. So now it's not necessary for me to access with the help of objects. All the static data members can be referred directly with the help of variable name or method name. We need not depend upon objects for the static data members. So here I'm calling the static variable from static context. So this SV is referred from the static context, and I'm also referring SV in an non-static context. So the static variables can be referred from both static and non-static context. And if you observe, we have not initialized the variable SV, that is your static variable. So all the uninitialized static variables will also be initialized by JVM with the default values of the data type. So the default value of integer type is 0. So that is the reason we got the value as 0. So even this, if I call method sum, so we did not get any error over here. That means all the static variables can be referred from both static and non-static context. Next, the uninitialized static variables also will be initialized by the JVM with the help of, with the default values of their respective data types. If we are trying to access the static data members of this class, now in class second, we have the variables S and R Now they are static variables. They are our static variables. So all the static variables can be directly referred when we are trying to access the static variables of one class into another class. They should be referred with the help of class name. They should be referred with the help of class name. So again, instead of writing yes, we should refer it with the help of class name. S is present in which class? Class second. So second dot s. Did we initialize this? Yes. No, we did not initialize it. So they will be initialized with the default values of the data type. What is the data type here? Int. So the default value of int is what? 0. So it has to print 0 twice with CodeBae. CodeBae 0 and CodeBae 0. Right. So this is the first value and this is our second value. So all the uninitialized static variables will be initialized with the default values. Now, the next point, now let's understand how does static variables refer with the help of objects. So can we refer them with the help of objects? So I have a static variable SV that is present in hello world and I have 3 objects. So we are trying to refer it with the help of OB. Still, we did not get any error there. So yes, static variables can also be referred with the help of objects, but the efficient way of invoking the static data members is with the help of class name. If you are trying to refer it in the same class, then directly refer with the variable name or method name. If you are trying to refer it in a different class, then refer it with the class name. So SV, I'm trying to access in the same class called hello world. So it's not necessary for me to refer it with an object. I can directly refer it with the variable name. And variable S, we are referring it in a different class. So for that, we have to refer it with the help of class name. Now let's look into the objects. How does static variables reflect or act upon the objects? So I'm writing OB dot SV, that is our static variable, equal to 23 semicolon. Next, I'm trying to change the values. OB1 dot SV equal to 33, OB2 dot SV is equal to 43. Now I'm trying to print SV value over here. Now what it will print? It will print me 43. The value of SV is what? 43. So now let's try to understand it, but now let's try to print with OB. OB.SV. Still the value is 43. OB1.SV. 43. So the difference is that this is how the instance variables work. This is how the instance variables work. Now let's understand how the static variables work. All the static variables share same memory across all the objects. So instead of having different memory location with different objects, we'll have static variable SV. Now first, all the objects are created, and when the statement is executed, now SV is initialized with 23. Right now, next, this particular statement is initialized. SV is given with 33. Now it will be updated in the same memory allocation. So now this 23 is given with 33. Now when you are writing with OB2.SV, and now this 33 will become 43. So that means what are the value that we are updating for the static variables with respect to the objects, always the value will be updated in the same memory location. Now all the objects will be accessing this particular memory location only. So whatever the value that we are updating at the last updated value will be reflected with respect to all the objects. That is, all the objects share same memory allocation with respect to the static variables. This is our static variable. Whereas instance variables share different memory allocation with respect to different objects. This is about our static variables. Now let's understand the points of the static variables. We've already discussed about the instance variables. The first one, static variables cannot be declared as the local variables. Now let's even understand this and get back to the points. Now let's try to understand or discuss, or let's try to understand the point over here. So here I'm defining a static variable. I'm removing all this additional code. Now I'm defining another variable, int ab, or local variable lv equal to 45. We know that all the local variables must be initialized by the programmer. So now this lv is a local variable because lv we have declared inside the block. Now let's try to make the local variable as the static variable. Error. Illegal start of expression. Illegal start of expression. That means we are not allowed to declare the local variables as static variables. So whenever we are declaring the local variables should not be static. When we are saying it's a static variables must be class level variables only. So we cannot have local variables as the static variables. So this is the first point that we need to understand about the static variables. Next, uninitialized static variables will be initialized by JVM with the default values of the respective data types. We have even seen that if you are not initializing any of the static variable, compiler will not raise you an error if you are directly accessing it, because all the uninitialized static variables will be initialized by JVM with the default values of the respective data types. Next point, static variables share same memory across all the objects. So this is the major difference between your static variables and instance variables. Instance variables share different memory allocation with respect to different objects, whereas static variables share same memory allocation across all the objects. If you are trying to change the value of one static variable using one object, that value will be reflected on all the remaining objects also. Static data members of one class can be referred from different class with both object and class name, but the efficient way of accessing the static variables is only with the class name. This is also we have understood. So when we are referring the static variables, they can be referred with the help of class name and object name. But whenever you are trying to refer the static variables of one class into a different class, they have to be referred, or they should be referred with the help of class name only, because that is an efficient way of accessing the static variables. Objects do not make any impact on the static variables. That is the reason we should always invoke them with the help of class names. Static variables can be referred from both static and non-static context directly. We don't have any restrictions on the static variables. Hope we are clear with the different kinds of variables. There are local variables, instance variables, and the static variables. Let's wrap up with trying to understand the points of all the local variables, instance variables, and the static variables. All the local variables are limited. The scope of the local variables are limited to a single block. Variables declared inside the method block or a constructor block or as passed as a parameter, all those kind of variables are called as local variables. Local variables must be initialized by the programmer before they are referred or accessed. That is, local variables will not be initialized by the default values. We don't have any default values for the local variables. All the local variables must be initialized before they are referred. JVM or Java does not print you the garbage values. If any of the local variable is uninitialized and if you're trying to refer or access them, compiler will raise you an error saying that variable might not have been initialized. And the scope or visibility of the local variables are limited to single block. They should be accessed in that particular block only. They cannot be accessed in the different block. So this is C is a local variable as this is passed as a parameter. Args is also a local variable and A is also a local variable. Instance variables. So all the instance data members cannot be referred from the static context directly. If you are trying to refer them from the static context, they have to be referred with the help of objects only. All the uninitialized instance variables will be initialized by the constructor with the default values of the respective data types. If the instance data members of one class can be referred from a different class with the help of objects of that particular class. Instance data members or instance variables share different memory allocations with respect to different objects. So that means instance variables can have different values with respect to different objects. As we have seen for IV, when we are referring with ob.iv, we got 23, ob1.iv 33, ob2.iv 43. So same variable IV, using the same variable IV, but when we are calling with different objects, we could get the different values. That is what the advantage of having the objects and instance variables. Static variables. The first and foremost point that we need to remember is static variables cannot be local variables. All the local variables must be non-static only. All the uninitialized static variables will be initialized by the JVM with the default values of the respective data types. Static variables share same memory across all the objects. This is again one of the important points that you need to understand with respect to the static variables. Static data members of one class can be referred from different class with both object name and class name. So when you are trying to refer it, we can refer it. All the static data members can be referred with the help of object name and class name. But the efficient way of accessing is with the class name only. Static variables can be referred from both static and non-static context. When we are seeing the static keyword can be used at class level, variable level, method level, and block level. So now we have seen using the static keyword at the variable level. Now at the method level. So if I'm making the static keyword for a method, this is called a method level. And if I want to access this method, as we know, all the static data members can be directly referred without the help of the objects. So I can directly refer it something like this. So it's not necessary for me to access it with the help of objects. Only the instance data members should be accessed with the help of objects. CodeBae, and this value is 0. And at the block level, so class level, if I make it at the class level, this is my outer class. So static keyword at the outer class is not allowed. They can be allowed at the inner class level only. Now this statement has to raise an error. Modifier static not allowed here. That is for the class keyword. So whenever you're making your class as a static class, that has to be inner class only. So what is an inner class? So let's discuss more about the inner classes later on. But now let's understand about the inner classes in a simple bit. If we're defining a class, inside a class is called an inner class. Now for this particular inner class, where is this class SS present? Inside the class second. So this SS becomes your inner classes. So for inner classes only, we can have the static keyword. But for the outer classes, we are not allowed to have the static keyword. So that is the reason static keyword is allowed at the inner class level only, but not at the outer class. So this is the other point that you have to remember, right? And next, static blocks. So now let's understand about the last usage of the static keyword, that is about your static blocks. Now this is my block, and for this block I'm just writing it as static, and in this block I'm trying to print something else. This is static method, as we are having the static keyword here, and sum is also static method. We are having a static keyword here. So this is a method block. This is also a method block, but whereas this is only the static block. So now let's make it more simpler for you. We are removing even this method. I'm even removing this class. Okay, let it be. Now, always the execution begin from the main method. So first, these two statements have to be executed. But now let's see what does our code look like. How does the output will be given as? Semicolon missing. Sorry. Double quotes not properly enclosed. Variable sv, we have removed the variable sv, so that is the reason we are getting another error. Sum, I think we also removed the sum method. Now if you can clearly observe, first static block has been printed, then only the main method has been executed. So always the execution will begin from the main method, but if the code consists of the static blocks, first static blocks will be executed, then only the main method will be executed. So if you want to define the static blocks, just define a block and use the static keyword above the block. So all the static blocks will be executed first. In a single class, we can have any number of static blocks. For example, I'm defining another static block, and in the static block we are writing something called Java. And now when a class consists of multiple static blocks, all the static blocks will be executed in the given order, and then only the main method will be executed. So that means first static block will be printed, then Java, and then CodeBae, followed by the print statements from the main method. So static block, Java, and CodeBae. If I just wanted to use println to print in a new line, static block, Java, CodeBae, and CodeBae. So this is about our static blocks. Static variable, static block, static method. So static keyword can be used at variable level, method level, block level, and only at the inner class level, not at the outer class level. So this is all about our static keyword. And the default values, once again, let's understand about the default values. For byte, the default value is 0. For short, the default value is 0. For int, the default value is 0. For long, default value is 0. Data type, their respective default values. Next, Boolean, the default value is false. Char, the default value is space. Next, float, the default value is 0.0. Double, the default value is 0.0. So all the static variables and instance variables. So all the uninitialized static variables and instance variables will be initialized with the default values of the respective data types. So this is all about the data types of, this is all about the variables, local variables, instance variables, and the static variables. Now just look into some of the few questions about these static variables and the instance variables. So can we define the static variables inside the static or non-static methods? So that means when we are defining any variables inside the method blocks, they become the local variables. So can we define the static variables as the local variables? So the answer is no. So we are not allowed to have the static variables as the local variables. We are not allowed to define any static variables inside any block. They have to be class level variables only. Can we access the instance variables from the static methods or static context with only the variable names? How should we access the instance variables from the static context? All the instance variables should be accessed with the help of objects only. So can we access the instance variables from the static context directly? No, they have to be accessed with the help of objects. Can we use the static keyword at the outer class level? No, static keyword cannot be used at the outer class level. They have to be accessed, or they can be used at the only inner class level. Can the local variables be accessed without initialization? No, local variables cannot be accessed without initialization. They have to be, or they must and should be initialized by the programmer. Local variables do not have the default values. Now let's try understanding the pseudocodes on the static keyword. So now the first program. So what will be the output of this code? What kind of variable X is? This is an instance variable. So where you are trying to access it from? The static context. And this is a static block. And from the static context, we are trying to access instance variable again. So this is an instance variable. This is also an instance variable X. So the point that we have understood from the instance variables cannot be referred from the static context directly. They have to be referred with the help of objects. So this particular pseudocode will raise you the compilation error saying that non-static variables cannot be referred from static context. So if I want to access them from the static context, we have to create an object. So how do we create an object? Test1, that is class name, followed by object name equal to new, followed by constructor, that is test1. So instead of calling it X, we'll have to call it with ob.x. Even in this block, we have to create an object. Why? We cannot use ob.x over here. If we use ob.x over here, we'll get an error. Why? Because this ob is a local variable. So we cannot access this ob in a different block. So here again, you have to create an object, test1 ob1 equal to new test1. So ob1.x. So no instance variables cannot be referred from the static context. They are directly. They have to be referred with the help of object only. Now coming to the next pseudocode. So this is the static variable as we have declared with the static keyword. And this is the main method. In the main method, we are trying to access it with X, that is with an object. So this is fine. All the static variables can be referred with the help of both class name, object name, and if you're trying to refer it in the same class, we can directly refer it with the variable name. And this is the static variable. In static variable, we can directly refer all the static variables can be referred from both static and non-static context. So this is also valid, but this is our static block. So first, this particular block will be executed. Always before executing the main method, static blocks will be executed. So now x value, initially the value of x is 10, but first static block will be executed. Now 10 will become 20, so it will print 20, and then the control comes here, then this 20 will be printed. So 20 will be printed twice. The 3 points that you can refer from this pseudocode. First, static blocks will be executed. Next, static variables can be referred from both static and non-static context, and static variables can also be called with the help of objects. Now, there's an k is an instance variable, Boolean is an instance variable, p is an static variable. All these three variables are uninitialized variables. So all the uninitialized static variables and instance variables will be initialized by constructors and JVM. So now let's see how does this code work. So we have a method over here, and this is an instance method. And in the instance method, we can refer both static variables and instance variables. So k is an instance variable, so this is valid. Is true is an instance variable, this is valid. P is a static variable, so this is also valid. So now we have created a second class. In the class, we are writing the main method, and I want to access the method called print value. Print value is an instance method. So when we are trying to access any instance data member of one class into a different class, we have to refer it with the help of an object. So we are creating an object class name, followed by object name, followed by assignment operator, followed by new, and followed by constructor. And using that, we are creating or accessing this method. So all the instance variables will be initialized by the default values with the help of a constructor. So this is the constructor. So it will initialize k with 0. This will initialize k with 0, Boolean with false, and this is 0. So the result will be 0, false, and 0. The last pseudocode. This is a static variable. We have the main method. From the main method, we are creating 3 objects, and we are accessing the variable a using d1 object. All the static variables, the point that we need to understand from this code is all the static variables share same memory across all the objects. If you are trying to change the value of one static variable using one object, the same value will also be reflected on all the other objects. So as we are changing the value of a by using 5, so initially this is our static variable a whose value has 2. Now we have 3 objects, d1, d2, and d3. So when you're trying to change the value of static variable a using d1, this will access this particular memory location, so the value will be 5. So when you're trying to access it with d2, they'll access the same memory location, d3 will access the same memory location, so the value is what? 5. So this particular statement will print 5 space 5 space 5. And now in this d3, using d3, we are changing the value. Now this value of 5 is being to 10. So all the static variables share same memory across all the objects. So this will print 10, 10, and 10. That is what the static variables is. So hope you are able to crack the pseudocodes. That's all about static variables, instance variables, and local variables. Which type of variables will be initialized by the default values? For what kind of variables will the default values be applicable? For both static and instance variables only. Do Java support global variables? No. Java do not support the global variables. What is the best or the efficient way to access the static data members of one class into a different class? So they can be accessed with both objects and class name. But what is an efficient way? The efficient way of accessing the static data members is with the help of class name only, with the class name. So hope you're clear with the concepts of static variables, instance variables, and local variables. Please follow us, subscribe us, and if you have any doubt, please you can reach us at CodeBae programming @gmail.com. Thank you.